Number 24 is another linear programming problem. Usually the long word problems are going to be those type. This one says an orchardist grows apples and pears to sell at a farmer's market. Based on previous sales, she has learned to bring only certain numbers of each fruit to market each day as listed. At least 200 apples, but no more than 300. So we want to have at least 200, but no more than 300. So the number of apples needs to be between those two. Let's call apples x and say that x is between 200 and 300. And then at least 125 pears, but no more than 175. So between 125 and 175. Each apple sold makes a profit of 35 cents. So it's 35 cents for an apple. Remember, apples were x. And each pear sold makes a profit of 40 cents. So 40 cents for a pear, pears were y's. You can transport a total of 400 pieces per day. So, sorry, I made this an x before. Let's fix that. So the x's and the y's together, we can only do 400 a day. So that has to be less than or equal to 400. All right, what's the maximum profit the orchardist can make each day? Well, our profit is represented by the amount of fruit that we sell and how much it costs. So the money equation down here, profit equals 35 cents x plus 40 cents times g. Now we need to graph these. And that sounds really tricky, but remember, if you have x equals inequalities, those are going to be vertical lines. So I'm going to have vertical lines that are solid lines because they're less than or equal to at 200 and 300. Vertical lines going up and down. So I don't have to actually physically draw the x and y axes. I can just visualize them. Then for the y's, y lines are horizontal. So I have y equals 125 for the pears, and the highest we can go is 175. The final equation we have is x plus y is less than or equal to 400. If I want to graph this one, it's not going to be horizontal or vertical. It's going to be diagonal because it has an x and a y in it. So I need to get y alone, and to do that I'm going to subtract x from both sides. Well, this line has a y-intercept of 400, which is going to be way far above the 175 on the y-axis. So y-intercept of 400, and then it's going to have a slope of negative 1 over 1. And since that's happening, we're going to end up having a point at 200, 200. I know that because if I substitute a 200 into this equation, negative 200 plus 400 gives me positive 200. So I'm going to draw a point at 200, 200, so a little bit above 175. If I substitute 300 into this equation, negative 300 plus 400 is 100. So 300 is paired with 100, a little bit less than 125. And if I substitute 400 into this equation for x, negative 400 plus 400 is 0. So my x-intercept is at 400, 0. And this is also going to be a solid line. And for this one, I'm going to be shading below it. So I'm shading below the yellow line and in between the pink and blue ones. So this is the area that I'm looking at for my feasible region. So now I just need to find what the vertices of that region are. Some of them are easy to figure out. This vertex is the intersection of 200 for x and 175 for y. So I've got 200, 175. This point of intersection is where 200 and 175 intersect. So the last one was 125. So 200 and 125, 200 and 175. And then for the other two, we've got to solve a little bit. At this point right here, the y value is 125. If I substitute that into this equation where y is, I have 125 equals or is less than or equal to negative x plus 400. So I'm going to try that. I'll write it down for you. 125 is less than or equal to negative x plus 400. I'm going to subtract 400 from both sides, and 125 take away 400 is negative 275. And then I've got to divide both sides by negative 1, so I get 275 is greater than or equal to x. So the value for x here is going to be 275. So 275 pairs with 125. And finally, I need to do the same for this point. So I have 4 vertices on my feasible region. For this point, my y value is 175. So I'm going to need to substitute that into the yellow equation that I have up here. And in order to make room for that, I'm going to erase my previous work. And I'm going to substitute 175 for y and solve for x by subtracting 400 from both sides, which gives me negative 225 equals negative x, or is less than or equal to, and positive 225 is less than or equal to x. So my fourth and final vertex is 225 and 175. Now we take each of these vertices and we substitute them into the objective function. This is going to allow us to see how many apples and pears we can sell to make the maximum profit, considering the restraints that we were given at the beginning. So first you're going to use this vertex. You can really do them in any order if you want to. Substitute 200 into the objective function for x and 125 into the objective function for y. This is where you're going to want to get your calculator out and do these calculations real quick. So I'm going to determine the profit for each of these ordered pairs of values. So when I tried all of those in the objective function here, my maximum profit that I could achieve came from this ordered pair, where I had 225 apples and 175 pears. 225 apples at 35 cents a piece and 175 pears at 40 cents a piece gives me $148.75. So that is the maximum profit that the orchardist can make each day, given the constraints that we talked about here. Number 25, Dr. Franklin begins an experiment with 100 bacteria in a container. She finds that the number of bacteria present at any given time is modeled by the following formula. And then I had a big jump because a page got interrupted. A sub 0 equals 100, and A sub n equals 2 times A sub n minus 1. N is the number of hours after the beginning of the experiment. So 0 hours after the beginning we had 100 bacteria, and we can continue calculating how many bacteria we have present using this recursive formula that they've given us. So it says how many bacteria are present 5 hours after the beginning of the experiment. So 0 hours after the beginning, remember we had 100 bacteria. Now according to this formula, if I want to find the next one, what this means is if I want A sub 1, so what happens 1 hour after we start the experiment, I'm going to need to use this formula where I substitute n, which in this case is 1, 1 minus 1. 1 minus 1 is 0, so that means this is the same thing as 2 times a sub 0. And a sub 0, as we know from the step above, is 100. So I've got 2 times 100, and 2 times 100 is 200. So basically it looks like I'm just taking the previous amount of bacteria and doubling it. So after 2 hours, I'll have 400 bacteria. After 3 hours, I'll have 800 bacteria. And after 4 hours, I'll have 1,600 bacteria. But this wants us to tell it how many are present after 5 hours. So I'm going to do a little jump down here. And I see that after 5 hours, I double once more, and I get 32,000 bacteria after 5 hours. So recursive functions, we just use what we had previously to get the next one. And to find the next one, we just look at what the recursive formula says to do. In this case, multiply by 2.